We are going to discuss about swap space management. We know swapping is moving processes between disk and main memory. Whenever there is less main memory, or when main memory reaches a low point, then to make more free space in the main memory, we are going to swap things out of the main memory. So this swap space management is one of the tasks that an operating system is going to perform. So a swap space may be used in two different ways. Any swap space may hold an entire process image, that is including its code and data, or it may simply store pages. We know what pages are. We have discussed about pages in paging. So a swap space may either hold a process image or it may store pages. And now this swap space location can be in one of the two places. That is, it may be present on the file system itself, or there can be a separate disk partition for this swap space. In this example, we are going to discuss how a swap space or how swapping is done on a Linux system. So a Linux system is going to have a swap area that may be, like I said, a swap file or a swap partition. That is, it may reside on a file system, or there can be a separate raw partition. Now each of these swap areas is going to have a series of 4 KB page slots. Now these page slots here, okay, each of these page slots, let's say, is of 4 KB. The capacity of this is 4 kilobytes, which are used to swap pages. So whatever pages are going to be swapped, those are going to be placed in these page slots. Now with every swap partition, there is going to be an associate, that is with every page slot, sorry, there is going to be a swap map, which is an array of integers. Now this swap map is going to tell with how many processes each of the page slot is associated. That is, whenever you have a 0 in the swap map, that means this area is not allocated to any of the pages. So here the second location and the fourth location in the swap partition are not allocated to any of the pages. That is, they are empty. Now we have numbers like 1 and 1 here. So these two represent that these two pages are associated with one process. We have a 3 here. So this value 3 indicates that the swapped page, that is the page that is present here, is mapped or is associated with 3 different processes. Thank you.